Two observation points A and B are 750 feet apart. And to give you a drawing, we have A and B 720 feet apart. From this point, the angle of elevation of the airplane at 46 degrees and 10 minutes and 63 degrees and 30 minutes from point B. We need to be able to find the height of the airplane. Now, when you draw the height, it has to be perpendicular to the x-axis, or to the ground in this case. So that's what we're trying to find, h. And since we draw perpendicular to the x-axis, this is going to be a right angle. So therefore, we have a right triangle in here, but in order to be able to find the height, I need to be able to find either one of those two sides. So from there, I can use SOHCAHTOA since we have a right triangle. But the only thing that I know is that this is 720 from A and B. So therefore, I want to be able to find as much information on this triangle as possible. If this is 63 in 30 minutes, I know that together will be 180. So therefore, I'm just going to go ahead and subtract 180 minus 63 in 30 minutes, and that gives you 116.5. But you should know that you have 30 minutes, so it'll be 116 degrees in 30 minutes as well, because 30 and 30 gives me an hour. And now, since I know 720, I'm going to find this angle here, so that way I can use the law of sines. I know that all three angles equal to 180, so I'm going to do 180 minus 46 degrees in 10 minutes minus 116 degrees in 30 minutes. And that gives me 17.3. So therefore this angle here is 17 degrees. And how many minutes? This is 10 minutes. This is 30, so it's a total of 40. So therefore there's 20 minutes left. If not, just multiply 0.333 times 60, and that gives you 20 as well. And now I can find this side here, and I'm going to call this x. Since I know a side and the opposite angle, therefore I can use my law of sines. So I'm going to find x. So x over the sine of 46 degrees in 10 minutes is going to be equal to 720 over the sine of 17 degrees in 20 minutes. And I'm just going to cross multiply. And I'm going to divide at the same time. So I'm going to cross multiply and divide by sine. So therefore x is equal to 720 multiplied by the sine of 46 degrees in 10 minutes divided by the sine of 17 degrees in 20 minutes. And I'm just going to type that into my calculator. And since I'm able to use my fraction, 720, make sure that you guys have on degrees the sine of 46 degrees in 10 minutes. It doesn't show you the minutes, but automatically recognizes that that's a minute, divided by the sine of 17 degrees in 20 minutes. Close my parentheses. And that gives you x is equal to 1743. They want two significant figures, so you can give me 1700 or 1743 should be fine. And that'll be feet. But I'm going to keep that into the calculator. I'm not going to erase it because I'm not looking for x. I'm looking for the height. So now that I have x, and since I'm using, now I have a right triangle, I can use SOHCAHTOA. So I don't need to use sine, cosine, or tangent. It's the opposite of our hypotenuse will be the sine. So I'm just going to use the sine of 63 degrees and 30 minutes. I'm going to be standing here. Is equal to the height over x. In this case, x is 1743. And now I'm just going to cross multiply. So therefore, h is equal to 1743 multiplied by the sine of 63 degrees and 30 minutes. Notice that I kept this into my calculator, and I'm just going to multiply my result multiplied by the sine of 63 degrees in 30 minutes. And that gives me 1560. So the height of the airplane is 1560, and that'll be feet. Now remember that you do need to make sure that you draw your extra triangle. This is a right triangle. So once you find x using the law of sines, you can use SOHCAHTOA to find the height.